previous videos we discussed about voltage and current, but I have a question for you. Is there any connection between the two of them? Is there any connection between voltage and current? Of course, there is a relationship between voltage across the conductor and a current passing through it. In this video, we are going to discuss about fantastic relationship between voltage and current. Okay, let us explore with the help of a small experiment. Okay, this is the open circuit. Okay, this is the open circuit. One cell, plug key and ammeter. Now I want to close this circuit with the help of a nichrome wire. Okay, this is a nichrome wire. It is an alloy of nickel, chromium, manganese and iron metals. Now I want to measure the voltage of the nichrome wire. So I connect the voltmeter across the terminals of the nichrome wire. Okay, now I switch on the circuit. The current is flowing in the circuit. Okay, don't think much about this symbol. This symbol is just the indication of the current. Okay, just don't think much of this symbol. Okay, so whenever I switch on the circuit, the current is flowing in the circuit. Now I want to measure the voltage and current with the help of voltmeter and ammeter. Okay, the voltmeter reading is 2 volt, ammeter reading is 1 ampere. Just insert the values in this table. Number of cells. In this part, this is the part A. Okay, we have 4 parts in this experiment. Part A, part B, part C, part D. In the part A, we have only one cell. The voltage is 2 volt, current is 1 ampere, and we have to do the ratio of V by I. V by I ratio. Voltage by current. Voltage by current. In the part A, what is the voltage reading? 2 volt. And what is the current reading? 1 ampere. So 2 by 1, the answer is 2. Okay. So in the part in the part A, we have only one cell. The voltage reading is 2 volt. Current reading is 1 ampere, and the ratio is 2. Okay, so next part B. In the part B we have 2 cells, right? In the part B we connected 2 cells, nichrome wire, voltmeter. Okay, now switch on the current. Okay, the current is flowing in the circuit. Can you guess how much the voltmeter and ammeter readings? Okay, the voltmeter reading is 4 volt. Okay, observe clearly, the voltmeter reading is 4 volt. Ammeter reading is 2 ampere. Okay, fine, that's good. This is the table. In the part B, we have 2 cells, right? We connected 2 cells. Voltmeter reading is 4 volt. Ammeter reading is 2 ampere. Okay. Now V by I ratio. Voltage by current. 4 by 2. The answer is 2. Wait. Why we getting the same V by I ratio? Why we are getting the same V by I ratio? I am getting the answer 2. In the first one, we have only one cell. We have difference in the voltage and current, but we are getting the same ratio. Why? What is the reason for that? Okay. Now it's time for part C. In the part C, we have 3 cells. We connected 3 cells. Nichrome wire, voltmeter, switch on the current. The current is flowing in the circuit. Okay. Can you find out what is the reading of voltmeter and ammeter? Just think. Just put a guess on that. Voltmeter reading is 6 volt. Ammeter reading is 3 ampere. Table please. Yeah. In the part C, we have 3 cells. Voltmeter reading is 6 volt. Current reading is 3 ampere. Again we have to do V by I ratio. 6 by 3 how much? 6 by 3 2. Wait, I am getting the same ratio. Again, why I am getting the same ratio? Why I am getting the same ratio for that? First cell, second cell, third cell. In the part A we have only one cell. In the part B we have 2 cells. In the part C we have 3 cells. But I am getting the same ratio. Okay, fine. Okay, and the last part D. In the part D we have 4 cells. We connected 4 cells. Nichrome wire, voltmeter, switch on the circuit, current is flowing in the circuit. Okay? Just guess what is the voltmeter and ammeter readings. Just guess. Just put a guess on it. Okay? Voltmeter reading is 8 volt. Ammeter reading is 4 ampere. Table please. Yeah, thank you so much. Number of cells connected 4 cells. Voltage reading 8 volt. Current reading 4 ampere. What is the V by I ratio? Again 2. 8 by 4 2. Oh my god. What is going on actually? What is going on actually? In part A we have only one cell. Voltage 2 volt. Current 1 ampere. V by I ratio 2. Fine, that's good. In the part B, we connected 2 cells. Voltage increases, current increases. But V by I ratio is same. In the part C, we connected 3 cells. Again, voltage increases, current increases, but V by I ratio is same. Again, in the last final part D, we connected 4 cells. We connected 4 cells, man. What is the voltage reading? 8 volt. Current reading 4 ampere. V by I ratio is again 2. Why I am getting same ratio? What is the reason for that actually? Okay, now I just want to plot the graph for these values. X-axis current, Y-axis voltage. Okay, whenever I plot the graph for these values, I get the straight line. I get the straight line. Why I get the straight line? Why I get the straight line? Because these values are constant. But what is the meaning of V by I? Why I am getting the same constant values? Even there is an increase in current and voltage. Okay, there is change in voltage and current. Why I am getting the same ratio? Why I am getting the same ratio? Okay, there is a main question we have. Just think, why we are getting the same ratio? Why we are getting the same V by I ratio? Just think about that. Voltage current graph for a nichrome wire. VI graph. VI graph means voltage current graph for a nichrome wire. Okay, a straight line plot shows that as the current through a wire increases, the voltage across the wire increases linearly. Simply it is called Ohm's law. Okay, observe clearly, the current through a wire increases, the voltage across the wire increases linearly. Observe clearly current voltage values. Okay, they are constantly increasing. They are constantly increasing. Okay, we get the same V by I values. We get the same V by I values. For suppose if you do the experiment really, you don't get these values. You get the approximate values. Just for your better understanding, I took these values. Okay, you get the approximate values if you do the experiment really. Okay, just for your better understanding, I took these values. But what is the meaning of V by I? That is the main question we have. Okay, actually in 1827, a German physicist, Simon Ohm, found out the relationship between the current and voltage. So scientist Simon Ohm found out the relationship between the current and voltage. So he stated that, observe clearly, this is the most important one. He stated that electric current flowing through a metallic wire is directly proportional to the potential difference across its ends, provided its temperature remains constant. It is the main one. Temperature remains same. Temperature remains constant. If suppose temperature changes, you don't get the same values, right? That's the main thing. He stated that V proportional to I. V directly proportional to I. What is the meaning of I? Voltage. What is the meaning of I? Current. V means voltage, I means current. They both are directly proportional to each other. Suppose in a circuit, if voltage is increases, then current also increases. Suppose voltage decreases, current also decreases. They both are directly proportional to each other. In a circuit, current is increases, voltage also increases. In a circuit, current is decreases, voltage also decreases. V proportional to I. They both are directly proportional to each other. Okay, now let's replace this proportionality symbol with equality by using constant R. Okay, I just replace this proportionality with the equality symbol by using constant R. V is equal to R into I. What is the meaning of R actually? What is the meaning of R? Okay, just rearrange the values. Just I'm rearranging the values. R is equal to V by I. What is this meaning of R? What is this meaning of R? R means resistance. It is the property of a conductor to resist the flow of charges passing through it. What is the meaning of resistance? It is a property of a conductor to resist the flow of charges. So, what is the meaning of resistance? It resists the flow of electrons. What is the meaning of resistance? It resists the flow of current. I think you get it right. So, SI unit of resistance is ohm, OHM. Okay, it is represented with the Greek symbol omega. Okay, this is a symbol to represent resistance. Okay, now see this image. OMP means ampere. It is the SI unit of the current. VOLT, volt, means it is the SI unit of the voltage. OHM, ohm, means It is the SI unit of the resistance. Okay, now see this. Current is flowing in the conductor. Okay, here voltage is pushing the current. Voltage is pushing the current. Oh, go man, go, go, go. Voltage is pushing the current. Okay, now see this guy. See this guy actually. Ohm, resistance. Okay, what he is doing? He is opposing the current. He is pushing back the current, right? I think see clearly. Okay, what is the meaning of resistance? He will resist the flow of current. Simply it is called resistance. So resistance means it is a property of a conductor to resist the flow of charges. I think you get it. Okay, so this is the formula to calculate voltage in the circuit. V is equal to R into I, resistance into current. Okay, this is the formula to calculate resistance. R is equal to V by I. Okay, that's good. Suppose if I want to find out current, then what is the formula for that? Simply I is equal to V by R. Okay, these are the three formulas we used to do numericals. Okay, fine. Okay, the current through a resistor is inversely proportional to its resistance. Okay, now see clearly. If in a conductor we have more resistance, means current is decreases. Okay, suppose in another conductor, if the resistance is very low, then the flow of current is very high. They both are inversely proportional to each other. If the current increases, resistance decreases. If the resistance increases, then the current decreases. There is a point you have to remember. Okay. Okay, now we have to do small experiment. Okay, in the place of nichrome wire, there is an LED bulb. Okay, now do the same experiment from part A to part D. Do the same experiment. Just increase the cells and calculate the voltage, current, and do the ratio of the V by I. Okay, so after the experiment, I get the graph like this. This is the graph for nichrome wire and this is the graph for LED bulb. But the graphs are not same. The graphs are not same, right? It is a straight line and it is the curve. Why? What is the reason for that? Actually, based on Ohm's law, materials are classified into two types: ohmic conductors, non-ohmic conductors. What is the meaning of ohmic conductors and what is the meaning of non-ohmic conductors? Okay, I will explain. Ohmic conductors means in the ohmic conductors, if you change current and voltage, there is no change in the resistance. In the ohmic conductors, the resistance is constant. But in the non-ohmic conductors, if there any change in the voltage and current, then resistance is also changes. In the non-ohmic conductors, resistance is not constant. So what is the meaning of ohmic conductors? Ohmic conductors means conductors which obeys Ohm's law are called ohmic conductors. And what is the meaning of non-ohmic conductors? Conductors which does not obeys Ohm's law are called non-ohmic conductors. So what is the meaning of Ohm's law? The potential difference across the ends of a resistor is directly proportional to the current through it, provided its temperature remains the same. Temperature have to be constant. If there is any change in temperature, then we get different values. Okay, so this is the formula: V proportional to I. I mean that if voltage increases, current also increases. If voltage decreases, then current also decreases. Okay, suppose if we want to calculate the voltage, this is the formula: voltage is equal to resistance into current. If we want to find out resistance is equal to voltage by current, and the loss formula current, I is equal to voltage by resistance. These three are very important formulas. Okay, just practice these formulas, right? Thank you.